All right, everybody. Today we are on lesson 8. I ready lesson 8. We have. All right, so let's go down to lesson 8. We are cruising on multiplication word problems, page 12. All right, guys. Let's read the directions for 1 through 9. Use a strategy of your choice to solve each problem. All right, we'll start off on number 1. The library has 5 mystery books on a shelf. It has 4 times as many fiction books on another shelf. How many fiction books are on the shelf? Alright, so first thing I'm going to do is I'm going to circle my numbers. 5 mystery books on a shelf. And then we have 4 times as many fiction books. So that means we have 4 times more fiction books. And then the question says, how many fiction books are on the shelf? All right, so I'm going to go ahead and I'm going to put M for mystery books. And we know we have 5 books. And I'm going to put F for fiction books. Looking back at the problem, we can see that we have 4 times as many as the mystery books. So it's 4 times 5. All right, and they want to know how many total fiction books are there. So let's set up an equation. We have fiction equals 4 times 5. So there's our equation with our variable. And remember, variable is your unknown value. So let's solve for F. So 4 times 5 is 20. So we know that fiction books equal 20. So we go up here and we write our answer in our complete sentence. There are 20 fiction books on the shelf. All right, this is one way to do it. Now I'm going to show you a different way to solve this problem. We're going to go ahead and set up a bar model. So here again, I'm going to put M for mystery books. And we know we have 5 mystery books. And then I'm going to use F for fiction books. We have 4 times as many. To save a little time here, I'm going to go ahead and cut and paste. So there's 1 times as many. There is 2 times as many. 3 times as many. And finally, 4 times as many. So then here you just add up all of your fiction books. Use your multiples of 5. So we'd have 5, 10, 15, 20. So we know that the fiction books equals 20. Fiction books is 1, 2, 3, 4 times as many as your mystery books. All right, number 2. Paul runs 2 laps around the gym. So that's Paul, and he's running 2 laps. Carrie runs 6 times as many laps as Paul. So how many laps does Carrie run? All right, so here again, I'm going to decontextualize the problem. I'm going to pull out all of my information and get rid of my words. So we start out with Paul, and we know that Paul runs 2 laps. And then we see Carrie runs 6 times as many as 2. So basically we just set up our equation with a variable. C is our unknown value, which is our variable, and we have to solve for C. And I know that 6 times 2 is 12. So C equals 12. So I know that Carrie has run 12 laps. All right, let's go ahead and show it representationally now. We're going to put Paul up here. Basically, representationally is a bar model, and we are going to have 2 laps here. All right, and then we set up Carrie, and I know that Carrie runs 6 times as many laps. There's 1 times as many, 2 times as many, 3 times as many, 4 times as many, 5 times as many. Whoops. 5 times as many, and 6 times as many. All right, so we can see in our bar model that we have 1, 2, 3, 4, 5, 6. So Carrie does 6 times as many as Paul. So do your multiples of 2 6 times, or you can just do 2 plus 2 plus 2 plus 2 6 times. And then we will get Carrie equals 12 laps. So we'll go ahead and fill in our sentence up here. Carrie runs 12 laps. All right, number 3. Violet has 3 markers. So this is Violet has 3 markers. She has 6 times as many colored pencils as markers. So 6 times as many colored pencils as markers. How many colored pencils does she have? All right, so this time there's just one person here, and we know her name is Violet, and we're basically finding the difference between our markers. So I'm going to put M for markers. Violet has 3 markers. So she has 3 markers, and she has 6 times as many as colored pencils. So I'm going to put P for pencils, and it is 6 times as many as 3. So we have our equation with our variable. Our unknown value is our variable. 6 times 3 will equal P. So P equals 6, 12, 18. So I know that Violet has 18 colored pencils. All right, that's one way to show it. Now I'm going to show you it using a bar model. So here's her markers, and I know she has 3 markers. And pencils, she has 6 times as many pencils. There's 1, 2, 3, 4, 5, and 6. So this is 6 times as many. So we do 6 times 3, or we could do our multiples of 3. Let's count them up. 3, 6, 9, 12, 15, 18. So I know that Violet has a total of 18 pencils. All right, Owen draws 7 comics in April. He draws 3 times as many comics in May. So how many comics does Owen draw in May? All right, so we know April, he draws 7 comics, and we know in May he draws 3 times as many comics in May. So 3 times April, which is 7. So we have our equation with our variable, our unknown value, and let's solve for M. M equals 21. So Owen draws 21 comics in May. All right, let's show you using a bar model. So in April, he draws 7 comics. Then in May, he draws 3 times as many as 7. So there's 1 times as many. There's 2 times as many. And finally, there's 3 times as many. So now we can do our multiples of 7. 7, 14, 21. So I know that in May, he has drawn 21 comics, which is 1, 2, 3 times as many as 7. All right, Tasha used 8 tomatoes to make salsa. She used 4 times as many tomatoes to make sauce. How many tomatoes did Tasha use to make sauce? So since both of them start with an S, we're going to actually write the word out. So salsa, we know there's 8 tomatoes to make salsa. And in order to make the sauce, we know she used 4 times as many as salsa. All right. Alright, so here's our variable, which is the word sauce, and here's our equation. Let's put our equal sign here. So let's go ahead and solve this. Sauce equals 32. So 32 tomatoes to make her sauce. Alright guys, now let me show you, let's show you using the bar model. Alright, so the salsa is 8. And the sauce is 4 times as many. Alright, so let's go ahead and copy that. 2 times as many. Alright, let me see. And then 3 times as many. 4 times as many. So we can see that our sauce equals 8, 16, 24, 32. So 32 tomatoes to make our sauce. And this is 1, 2, 3, 4 times as many as 8 is 32. Alright, there are 7 pear trees on a farm. There are 7 times as many apple trees. So we have 7 pear trees on a farm. We have 7 times as many apple trees as pear trees. How many apple trees are on the farm? So we have pear trees, 7. We have apple trees is 7 times as many as pear trees, which is 7. Alright, so we have our equation with our variable, our unknown value. Apples equals 7 times as many as 7 pear trees. So 7 times 7 will equal 49. I know there's 49 apple trees. Alright, so let's go ahead and show you using the bar model. We have pear, which is 7. Alright, and now I need to find my apple trees, which is 7 times as many. So here's our apple trees, and we have 1 time as many. There's 2 times as many. 3 times as many. 4 times as many. 5 times as many. 6 times as many. And 7 times as many. Alright guys, so now we can see that my apple equals 7, 14, 21, 28, 35, 42, 49. We have 49 apple trees, and that is 1, 2, 3, 4, 5, 6, 7 times as many as 7. Alright, there are 9 school buses in a parking lot. There are 6 times as many cars. So we have 9 school buses. We have 6 times as many cars as school buses in the parking lot. How many cars are in the parking lot? Alright, so I'm going to put B for buses, and we know there's a total of 9. And then I'm going to do cars, and I know there's 6 times as many as buses, which is 9. So I have my equation with my variable, which was my unknown value. C equals 6 times 9, and 6 times 9 is 54. So I know that there are 54 cars in the parking lot. Alright, let's show you the bar model. So I know that buses equals 9. Alright, and then I know that my cars, there are 6 times as many. Alright, here's 1, 2, 3, 4, 5, and 6 times as many. So there's 6 times as many. So cars equals 9, 18, 27, 36, 45, 54. So I know I have a total of 54 cars, which is 1, 2, 3, 4, 5, 6 times as many as 9. Alright, there are 8 vases at an art show. There are 9 times as many paintings as vases at the art show. How many paintings are at the art show? Alright, so we have V for vases, and vases equals 8. And then we know painting equals 9 times as many as 8. So we have our variable which is our unknown value, and this is our equation. We're solving for paintings. How many paintings are there? 9 times as many as 8 vases. 9 times 8 equals 72. So I know my paintings equals 72. Alright, let's show your bar model. Vases equals 8. Alright, then paintings equals 9 times as many. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Alright, so we have a total of 8, 16, 24, 32, 40, 48, 56, 64, 72. So there's a total of 72 paintings, which is 1, 2, 3, 4, 5, 6, 7, 8, 9 times as many as 8. Finally, number 9. Write and solve a word problem for this equation. 5 times 6 equals question mark. Alright, Marcus answered 5 questions on IXL. Caleb answered 6 times as many questions as Marcus. How many questions did Caleb answer on IXL? So we have Marcus answered 5 questions. Caleb answered 6 times as many. So here's Marcus, and that would be 5 questions. And Caleb would be 6 times as many as Marcus, which is 5. We have our equation with our variable, our unknown value, and 6 times 5 would give us a product of 30. So Caleb answered 30 questions. Alright, let's show the bar model. We have Marcus. We'll go ahead and fill in 30 here. Marcus answered 5 questions on IXL. Caleb answered 6 times as many. We have 1, 2, 3, 4, 5, 6. So we have 6 times as many. That'd be 5, 10, 15, 20, 25, 30. So Caleb answered 30 questions on IXL, which is 1, 2, 3, 4, 5, 6. 6 times as many as 5. All right, guys, I really appreciate everybody watching our lessons today. Great job. Let's keep up the good work, man. You guys are awesome. All right, see you tomorrow.